well, there's an ASTM committee, the F42 committee, there's the British Standards Committee, that I used to chair, and I've just moved on from doing that. And there's also the ISO committees in Europe. There's a lot of people looking at it. The definitions, however, leave a little bit to be desired at the moment. So additive manufacturing is where you add material as opposed to subtractive manufacturing, when you take it away. We've got a bit better at it since then, but ultimately, there's a lot of work to be done in coming up with these standards. There has been a lot of work done in moving the standards forward. And there are standards out there for aerospace titanium already, so that's perfectly acceptable for manufacturing. Right. So some very, very early bits. This is from the Hochschule at Westfalen, but they did a project where they were looking at indirect AM, which is, to you and I, that would be rapid casting. You take sand, you print a binder into that sand to create a mould for manufacturing these parts. They did them in steels, they did them in aluminium, they did it in a sort of mixture of polymer, and they did a direct version. Polymer and aluminium, and they were looking at doing that. And of course, that's what it looked like close up, and you could come up with this and change the design, and it was nice and modular, and it reduced the weight of your structures by a significant amount. And this was very exciting. This was some young chaps, PhD, some time ago. This again was something that Arup showed a couple of years ago. It showed that was the connectors that they were based sort of design study on it. They got it down to this mangled thing and then further down to there. But this shows that what you've done is you've both reduced the size. These are all supposed to have the same functionality. Reduce the size, change the form. Now whether you think that that's a good idea or not, it's the kind of design freedom that it allows the designers it allows people to explore a little bit. And I think when we allow people to explore the outer reaches of their engineering capabilities, I think we actually start to touch on some interesting new ideas that can maybe change and drive us forwards in our various industries. But one of the things I would like to point out is it's been around for quite a while. This is the first pattern. This was actually on the front cover of this one. So this one was 1926, and it was using an electric arc to generate 3D objects depositing molten metal and similar layers. If I'd been the artist for this, if I'd been writing the pattern, I would have made my parts look a bit better. Because they do look a bit rubbish. But you get the point there, you can see what they were attempting to do. And this is from 1971, but the original filing was 1969. So that's been, and this is for making sections of pressure vessels. So this has been around for a long time. And I always think that when I see this, I always think of this fella here. Now I reckon this is the guy, he's been in every audience, I guarantee it, I've done presentations that for a very long time. So, okay. Yeah, it takes a while when you see it. You go, right. And the other thing is to bear in mind that we are in the process of it being height to head as well. Okay, and the Gartner height cycle, which I think is a wonderful thing, tells us how we can understand just where we sit in terms of our understanding of how the technology is moving on. Now this is from 2011, and if we look over here, 3D printing is here. The year after this, when GE bought platforms, it was over here. How that happened that quickly, I'm not sure. But I love this. You've got a technology trigger in this one. The peak of inflated expectations. It's when everybody says that 3D printing is going to save the world and cause the alignment of planets and everything. Then we go through the trough of disillusionment, which I think is the best part there. This is when you realise that it's actually quite challenging and you've got to put in the time and the money and the effort to make sure that this is qualified. And then we move into the slope of enlightenment. The interesting thing is over here, adopting at this point here, actually puts you at a disadvantage because your competitors are back over here looking at the next technologies that are emerging. So a lot of the aerospace sector, and now certainly the biomedical sector, has been looking at things while it's been here so that they can be sure to be ahead of their competitors. And like with all of these things, this is it. We've got to go from there to there, and at the moment we are a little bit here, so do mind the step. Okay, so, but like I say,